Hello, great students and viewers out there. You are welcome to today's teaching. I am your friend and your teacher, Muotoh Chinenye from the Department of Mathematics in St. Charles College, Onitsha, Anambra State. Our subject for today is further mathematics, and I'll be taking you on a topic called permutation. Sit back and relax, because by the end of this lesson, I expect you should be able to evaluate problems on factorial, solve problems on permutation, and state at least 3 permutation formula and when to use them. Before we go into the topic proper, we'll look at an aspect called factorial. And factorial is a symbol of exclamation mark. That's like this. And n factorial is expressed as n times n minus 1 in brackets times n minus 2 in brackets down to 3 times 2 times 1. Then if you are to evaluate 4 factorial, that will give us 4 times 3 times 2 times 1, or 4 factorial can also be expressed as 4 times 3 factorial. Then let's look at more examples. Simplify 4 factorial over 2 factorial. Remember, 4 factorial has been expressed as 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. Then when you simplify, you are going to have 12 as an answer. Example 2, n factorial all over n minus 2 all in bracket factorial. N factorial is the same as n times n minus 1 in bracket times n minus 2 in bracket factorial all over n minus 2 in bracket factorial. The n minus 2 in bracket factorial at the numerator cancels the n minus 2 in brackets factorial at the denominator, and that gives us n into n minus 1. When you expand, you are going to have n squared minus n as your answer. Very importantly, you can also use calculator to find factorials. Supposing you want to get 5 factorial, what you simply do is to press your button 1, which is 5, then press your button 2, which is shift, and then your button 3, which is x raised to power minus 1. Then you press finally the equal sign, and that gives us 120 ways as our answer. Now let's go to the topic proper, permutation as arrangement. Then permutation is simply arrangement, and its arrangement, order of arrangement is very, very important. Examples. Number 1, in how many ways can the word yes, Y-E-S, be arranged? Solution, you observe that Y has 2 ways of arrangement, which is Y-E-S and Y-S-E. And E has 2 ways of arrangement, which will give us E-S-Y and E-Y-X. Then S has 2 ways of arrangement also, which will give us S-E-Y and S-Y-E. When you count the total arrangements, you are going to have 6 ways. Alternatively, you can also count the letters of the word yes, and having known that the letters of the word yes are 3, you have 3 factorial. And 3 factorial, when you simplify, will give us 6 ways. Example 2. In how many ways can 3 girls and 2 boys be arranged in a row? Remember, when arrangement is done in a row, it's just the same thing as when it is done on a line or when it is done on a bench. Now, what you do is to add the number of girls, which are 3, and the number of boys, which are 2, to give us 5. And then you have 5 factorial, which when you simplify, will give us 120 ways. Example 3. In how many ways can the letters of the word median, median is M-E-D-I-A-N, be arranged? How many of these ways begin with M? How many end with N? And how many begin with M and end with N? Solution, median has 6 letters, and to get the number of arrangements, we have 6 factorial, which when you simplify, will give us 720 ways as an answer. Then let's go to numbers that will begin with M. What you simply do is to remove the letter M from the word median and the remaining letters are now 5. Then you have 5 factorial, which when you simplify, it will give us 120 ways. Then to know the ones that will end with n, to end with n is the same thing as beginning with n, which was exactly what we did in I above, Roman figure 1 above. Then n factorial, those that will end with n, you still do remove the letter n from the word median, and the remaining letters are 5, so we have 5 factorial. And when you simplify, you have 120 ways. Then finally, to know the numbers that will begin with m and end with n, you remove the 2 letters m and n from the word median, and the remaining letters are 4. So we have 4 factorial, and when you simplify, it will give us 24 as an answer. Then I would like you, just as you are listening, to get me the number of arrangement of the word COVID, C-O-V-I-D, and give me the answer before the lesson ends. Permutation formula. Permutation formula, taking n objects and r at a given time, is given as n permutation r is equal to n factorial over n minus r, all in bracket factorial, provided your n is greater than r, or that your n is equal to r. I hope you are learning something. Let's take that formula again. Permutation formula is given as n factorial over n minus r, all in bracket factorial, provided n is greater than or equal to r. Then let's look at examples. Evaluate 3 permutation 2. Using the formula, our n is 3 and our r is 2. And that will give us 3 factorial over 3 minus 2, all in bracket factorial. And when you simplify that, it gives us 6 as an answer. Example 2. If n permutation 2 is equal to 12, find the value of n. Solution, our n still remains n from the given formula, and our r in this question is 2. Then when we substitute, we are going to have n factorial all over n minus 2, all in bracket factorial, equal to 12. Expanding n factorial at the numerator, you are going to have n, all in bracket n minus 1, all in bracket n minus 2 factorial, over n minus 2, all in bracket factorial, which is equal to 12. Then simplifying further, we have n, all in bracket n minus 1, is equal to 12. Expanding and factorizing, we have n squared minus n minus 12 equal to 0. Applying your factorization proper, we have n squared minus 4n plus, in bracket, 3n minus 12, all equal to 0. Remember, we chose minus 4 and 3 to replace minus 1 as the coefficient of n in the question, because minus 4 plus 3 will give us minus 1 as the coefficient of n, and minus 4 times 3 will give us minus 12 as the last term. Then when you simplify further, we are going to have n as minus 3 and 4. However, n must not be negative. Then we have our value of n to be 4. Number 3, there are 12 horses in a race. If we are concerned with the first, second, third, fourth, and fifth place finishers, how many different orders of finish are possible? Then we have our n in this question to be 12. Our first, second, third, fourth, and fifth means that our r is 5. Then when we apply the permutation formula, which is seen at the foot of the screen, we all have 12 permutation 5. When you simplify, you are going to have 95,040 ways. Using your calculator, remember also, you can also use calculator to get permutation. And to do that, if you are getting 12 permutation 5, you simply press button 1, which is your 12, then button 2, which is shift button, press button 3, which is the multiplication button, and button 4, which is your 5. And when you do that, you have your answer as 95,040 ways. Arrangement of identical objects. When objects are identical, it means the letters of the word are repeated. And to do that, we use the formula n factorial over r1, r2 down to rn. Remember, we use r sub 1 and r sub 2 down to r sub n to represent those repeated letters as used in that particular word. Let's take, for instance, example 1. How many ways can the letters of the word mathematics be arranged? You know, mathematics has total number of letters to be n as 11, and you observe also that your m is repeated as 2, a equal to 2, and your t equal to 1. Other letters like c and I are just 1. Then when you apply the formula above on the screen, you are going to have n factorial over 2 factorial, 2 factorial, 2 factorial at the denominator. When you simplify, you will have 4,999,600 ways. Example 2. In how many different ways can I place 3 white balls, 2 green balls, and 1 black ball in a line? Remember, I told you earlier that a line is the same as a row, which is the same as a bench. So when arrangements are placed on a row or a line, you have our white is equal to 3, our green balls are 2, and our black ball is 1. So when you add them together, we have 3 plus 2 plus 1 to give us 6 factorial. We divide the 6 factorial by 3 factorial and 2 factorial because there are repeated colors of the ball like white and green. And when you simplify, you will have 60 ways. Another aspect of the topic is cyclic or ring permutation. For arrangement on a circular or round object, circular object is just an object in a table form, object in a table that cannot be moved. When you have such objects, the formula to use is n minus 1 all in brackets factorial. Then when an object is on a ring, which can be turned over, just like this key I am holding is done on a ring, and because it can be turned over, our formula there is n minus 1 all in bracket factorial all over 2. We divide by 2 because to avoid the repetition of arrangements. Then let's go to examples. 2 sisters and a brother are to have a dinner jointly. In how many ways can they sit at a round table? In that case, 2 sisters and a brother means n is 2 plus 1, which is 3. And remember, for a round table, we are going to have 3 minus 1 all in bracket factorial, which when you simplify, it gives us 2 ways. Now let's look at another way you can do it. The diagrams there are showing the table. Now, if you place the first sister, which is presented as S1, the second sister may decide to sit beside her, which is S sub 2, and the brother will sit after the second sister, which is presented as B. Or you can decide to arrange it in such a manner that the first sister takes the first position, and the brother sits beside, and then the second sister, sits after them. In that arrangement, we are having 2 ways of arrangement. Example 2. 6 different keys are kept on a circular key ring, just like my key. How many different of these keys are there? In that question, our n is 6. And in the arrangement, because it's done on a ring, which can be turned over, we have 6 minus 1 all in bracket factorial over 2. And when you simplify, you are going to have 60 ways as your answer. I hope you are still with me out there. Then we quickly look at another very, very important aspect of this topic we call conditional permutation. And from the word conditional, it is an if permutation. There is a clause of condition attached to the questions on this. Then let's look at some of the examples. Example 1, a family of 6 is to be seated in a row. In how many ways can this be done if the father and mother are not to sit together? WAEC 2006. Before we go into answering this question proper, let's look at some aspects of this question. The family of 6, remember, is made up of father, mother, and 4 children. So if we are having normal sitting arrangements, which is normal sitting means that the father can decide to sit anywhere he likes, the mother can sit anywhere he likes, and the children can sit anywhere they like. In that arrangement that is done without restriction, we have total number of ways is 6 factorial, which when you simplify will give us 720 ways as an answer. Also, another aspect of it is when the father and the mother choose to sit together. If they are sitting together, you count the father, which is represented as F, and the mother, which is represented as M, as 1. That means count the father and mother as 1, add them to their 4 children, and when you do that, you are going to have 5 factorial. But remember, the father and mother have 2 ways or 2 factorial ways of sitting. Then when you collect them together, we are going to have 5 factorial times 2 factorial, which will simply give us 240 ways. Alternatively, you can use the diagram as seen on the screen. The children will decide to sit first, showed with the arrows, and for them to sit, we have 4 factorial ways of their sitting. Then if that is done, the father and mother may decide to sit before the first child, which is C1. The father and mother may also decide to sit in between the first child and the second child, that is F and M. The father and mother can also sit in between the second child and the third child. They can also sit in between the third child and the 4th child. And they can also sit after the 4th child. Remember, for the father and mother to sit, they have already 2 factorial ways of sitting because they are 2. And when you collect them together, we are having 5 times 2 factorial for the sitting arrangement of the father and the mother, times 4 factorial for the sitting arrangement of the children. And when you collect them together, simplifying, we are going to have 240 ways as our answer. Then let's go to the question proper. The question said, father and mother not sitting together, meaning they cannot sit together, they cannot be seen close to each other. In that case, the children will have to sit first. For them to sit first, they will have 4 factorial ways of sitting. And the father, when the children have settled, the father will have 5 spaces to settle on. And when he finally settles on 1, then the mother will have the remaining 4 spaces to occupy. And when that is finally done, we are going to have 4 factorial times 5 times 4, which is equal to 480 ways as our answer. Using the diagram there, you can also see it. Alternatively, you can simply do, for the father and mother not to sit together, you have normal sitting, which I told you is sitting without condition, minus the sitting together. And normal sitting, as you have solved already, gave us 720 ways, minus sitting together, which gave us 240 ways, which is equal to 480 ways. It means that the answer to the above question is 480 ways. Other ones we did were to add in getting the answer to that question. What it means is that a student may decide not to go through those processes. He will just find the father and mother not sitting together with the formula as 4 factorial times 5 times 4, which gave us 480 ways. Now let's look at example 2. The letters of the word digits are to be permuted. In how many of these permutations do the i's come together? B. Are the i's separated? Solution. The word digit has 5 letters, meaning that our n is 5. And because i's are repeated 2 times, our I is 2. So if we are doing without restriction, we are having 5 factorial over 2 factorial. Remember, without restriction, as I have said, means there is no condition. Arrangement can be done anyhow you like. In that case, when you simplify 5 factorial over 2 factorial, you are going to have 60 ways. Now, going to the answer to the question proper, when the i's are coming together, what you simply do is to count the 2 i's as 1. Add them to the remaining letters of the digits, which are D, G, and T, to be 4 factorial. But remember, your i's have 2 factorial ways of arrangement because they are 2 letters. Now, since the i's are also repeated, what you simply do is to divide your result by 2 factorial. And when you do that, you are going to have 4 factorial times 2 factorial all over 2 factorial. And when you simplify, you have 24 ways as your answer. A student can alternatively do it this way. Place the remaining 3 digits, which are D, G, and T. And the 2 i's will decide to come before the D. Or it can also come in between D and G. It can also come in between G and T. And finally at the end of T. And when you do that, for D, G, and T, it will have 3 ways of arrangement. Then the i's taking their places in between these letters, we have 4 spaces. And when you simplify, we are going to have 3 factorial times 4. And that will give us 24 ways as an answer. Then let's go to answer to question B. I separated means that the D, G, and T have 3 ways to settle. When D, G, and T are settled, first I will have 4 spaces to occupy, while the second I will have 3 spaces left over. Since i's are repeated twice, you simply divide the result you have by 2, and that will give us 3 factorial times 4 times 3 all over 2 factorial. And when you simplify further, you are going to have 36 ways as an answer. You can also do it by having the number minus when the 2 i's are together. And when you do that, for normal, it is 60. For the 2 i's coming together, it is 24. Then when you subtract 60 and 24, you are going to have 36 ways as our answer. Example 3. In how many ways can 4 men and 2 women be seated at a round table if the women do not sit next to each other? What does this question mean? This is a round table, and the women and the men are to sit on this table. But the women must not sit next to each other. That means they will not sit closer to each other. So how do you solve? Using the diagram, you have the women may decide to take first sitting, then the 4 men would sit. For the 4 men to sit, we have 4 factorial ways, while the second woman, having noted that the first woman have settled, we have 3 places to sit, and that will give us 4 factorial times 3. And when you simplify 4 factorial times 3, we are going to have 72 ways. I hope you have learned something today. And remember, I told you earlier that I expected you to do some things for me to really prove to me that what I taught really assimilated in your brains. To do that, I have the following questions for you to do for me. Number 1 question is, how many 4-digit numbers can be formed using the digits 1, 2, 3, 4, and 5, provided the digits are not repeated? 2. The password for Goma's email account consists of 5 characters chosen from the set GOMA M, E, and R. How many arrangements are possible if the password has no repeated characters? Example, question 3, Evaluate Roman figure 1, 10 permutation 4, Roman figure 2, n minus 3 in bracket factorial over n minus 5 in bracket factorial. Roman figure 3, if n permutation 2 is equal to 12, find n. Then Roman figure 4, if x permutation 3 is equal to 24, find x. Number 4, an examination paper has 6 questions, but only 4 are to be answered. In how many different ways can the answers be arranged? Number 5, in how many different ways can the letters of the words be arranged? Roman figure 1, notable. Roman figure 2, shallow. Roman figure 3, pandemic. Roman figure 4, calculus. Roman figure 5 has A, okinkwo. B, in how many ways of this arrangement does O occupy both end positions of the words? I want you to remark this, that for O to occupy 2 end positions of the word okinkwo, it means that O will begin the letter and O will also end the letter. Remember the ones I've taught you. Use the format to answer this question for me. Then still on number 5, write out your name for me and arrange them. Number 6, in how many ways can 5 boys and 3 girls sit in a line? If Roman figure 1, there is no restriction. Roman figure 2, the girls sit next to each other. Roman figure 3, the girls do not sit next to each other. And the other questions under this, kindly do them for me and submit to my WhatsApp number for more inquiries. The number here is 080 69 46 71 and 27. I take it once more, 080 69 46 71 27. Thank you very much for your time and your data and your audience. I really appreciate. Hope to see you some other time. Bye-bye.